Hello and welcome to this new tutorial series where we're going to create a small roguelike stealth-like game using SpriteKit and a character-based graphics solution that will mimic using a console. So let's get started. So what we're going to create is we're going to create a game called MiniStealth, and the objective is to move and play a character from start to finish in a grade-based map, all the while not being caught by any of the enemies. Your visibility will be limited, and enemies will have basic AI that can find and chase you. So let's show the game first. So this is a working demo, and I can move around using the arrow keys, and if I do, various parts of the game will be visible. I can see the cones of visibility of the adversaries, and I can sneak past them. Unfortunately, I get caught. They start chasing me, but fortunately I'm able to reach the treasure in time and go to the next level. So that's a very quick demo, and that's the game we're going to make. So we'll include everything you saw, like the field of vision, the audio effects, and so on. We're going to be using a sort of character-like display that divides our screen up into different cells. We'll call it an SK console, and we will be able to put characters at places on the screen, not just characters, but also, like you saw in the previous demo, graphics at places. But we'll start with creating just being able to put text on various places on the screen. We will have an 80 column wide display, and we will have 44 rows. Those dimensions I chose because those will fit on almost any Mac screen, and will also allow us to do so using integer scaling of sprites and character glyphs. That way we get that crispy, clean pixel art like look. So I don't want the fuzziness you get if you have anything other than integer scaling. And we will interact with the console in a pretty simple way. We'll have ways of putting characters at a place, putting strings at a place, choosing colors, and we will have cells that are 16 by 16 points. Those points will translate directly into pixels for graphics, giving that pixel art look, and they will translate to 32 by 32 pixels for characters, so we can still have nice and clean looking text without any visual artifacts. And so our console will be a simple SpriteKit node, and that way we can add it to the game scene as a node. We'll specify the size only using numbers of rows and columns. So we will, when we interact with it, we'll just be talking about coordinates in an integer space on which row, which column. And we'll interact using a very simple API to start. So we'll put characters, we'll put strings, and we have a way of clearing the screen. We'll put the characters and strings at a type called a vector, that is basically an x and a y coordinate, but we call it a vector because you could also use it as a direction. And we will be able to specify color. In the future we'll add a way of adding background colors as well, but this is a good place to start. What this thing will do internally is create a SpriteKit node for every for every cell in the console, and we will map characters to the textures. So we'll load images from the apps bundle, and those images will be the characters we display in the sprite nodes. And we will be caching textures so that the same character can appear on the screen multiple times without having to reload it each and every time, or without bloating the memory requirements by having basically the same information loaded many times. We will also need a way of describing a coordinate or a position or a direction. That's why we call it a vector and not just a coordinate. We use a type that stores them as integer values, and we'll call a vector called structure called vector for this. And we'll add some operators and convenience methods so we can perform basic arithmetic-like operations on these vectors, like addition, subtracting, calculating the length, both as a Pythagorean length as well as the Manhattan length. That's the length you have when you only can go sideways or up and down. And we might add even more if we need them at some other time. The Apple does provide a type for integer vectors called the vector underscore into. That's part of the accelerate library. However, I find it quite difficult to use because its intended use is in SIMD instructions, and it's pretty low level. That's pretty low level programming. Focus is on performance over ease of use, and well, in our case, performance is absolutely no issue when it comes to describing these types of coordinates. That's why we're rolling our own data structure for this. And that's also what all we're going to do for today. So what we're going to do is we'll take this in a couple of steps, and we'll go through each one in sequence, and we'll start by creating the project and then getting rid of all the standard code, example code and files, because there's quite a lot in the Xcode template. So let's start Xcode. Create a new Xcode project. We'll create a macOS game. We'll call it MiniStealth. It will be using Swift, SpriteKit, and we can include tests. We don't have to check the integrate GameplayKit yet. We will add it manually later when we need it. We need a place to save it, sure. And then we get a templated basic SpriteKit application. The template contains a lot of stuff that we don't need, so it's more or less more an example program than a scaffold or a template. So we need to start by removing these scenes objects. Delete. We have our game scene here that contains a lot of data. We'll start by just getting rid of the the stuff in the view controller we don't need. So let's see, we do need the outlet that maps the view to the view controller. We need the super view that loads. What we don't need is, we're not going to load the scene from a file, but we're just going to instantiate a game scene directly. That does not return optional, so we can get rid of that one. So we'll have a scene called game scene. Let's see, we do need the scale mode for the scene, and we'll set it to aspect fit for now. That means that we will always see the entire scene on the screen. and there might be letterboxing involved if it doesn't fit correctly. We'll fix it. We'll fix that at a later time. We will present the scene, and then set some additional information. That's a performance optimization. FPS is nice to have, node count is nice to have. This should be enough for now. We will also need to get rid of a lot of code in the game scene file, so we'll get rid of these variables. In the did move to view, we don't need to the label, the spinny node, etc. So this will also all be removed. We don't need any of these methods. And we can actually keep the key down, but we'll just get rid of this case because we will add our own later on, and we can keep the update method because we can start using that at a later time. So we now have a bare bones empty SpriteKit project that we can start using to create the game. So that's step 1. Then step 2, we created an empty game scene, and what we now need to do is add character graphic assets in our bundle. And let's see, so we have our assets here, and in the link in the description below you can find a link to the characters and the tiles. These are the files we're going to use, and we just need to have, let's create a folder first, and we just need to have the from 0 to basically all the PNG files. The original Pixelmator file is also there if you want it, but you don't need it in the project. So now these are added to the project, and then we can finally start coding. So, and we will start by implementing our vector structure. So create a new Swift file, vector.swift, and let's see, it will be a structure called vector. And for now we mostly need an x coordinate and we need a y coordinate. I think this is enough for our first implementation of our sConsole class. So we'll create a new file. Our sConsole.swift. And we will start by creating a new class, which will inherit from skNode, and we will have a row count, integer, and we have a call count, integer, and we'll have an initializer that takes a call count and a row count, and at least it will set the row count to the row count passed in. We'll also call our super.init because that's mandatory, and then don't forget to import SpriteKit, so we have access to these types. Now we need a place to, if we want to change what you see on the screen at a specific coordinate, we will need a place where we can place all the SpriteKit nodes that make up the various characters on the screen or the various cells on the screen. So let's create a private variable called FG nodes. I'm calling it FG nodes because these will be our foreground nodes, and we will add background nodes at a later time. And this will just be an array of SpriteKit nodes, and initialize it as an empty array. And for now, let's just try and get something on the screen. So what we'll do is we'll have a texture. I'll call it SK texture. And I think there should be an asset or a character here for a space. Now that one is empty. I think we need one additional tile, and not just a tile map. We need these PNG files as well. So we'll create a separate folder called tiles and add the PNG files there. And we have a square 16 by 16, and that's the one we will be using to show that we actually have information on the screen. So we'll load this texture. We'll set the texture.filtering mode to nearest, so we get we don't get any blurring due to resizing. And now we'll go and look at every cell on the scene. So we'll go for every row from 0 to row count, and for every column we'll create a new foreground node called an SK sprite node, and we'll use the texture we just loaded. We'll set its position to a CG point of 8 plus 16 times X, and a Y coordinate of 18 plus 16 times Y. And the reason we do that is we decided that these nodes were 16 by 16 points wide and tall, and because the anchor is in the middle, we need to offset them by 8, so to prevent the first column and the first row being cut off from the screen. And this is our position. We'll also set a color blend factor. By setting this to 1.0, we can recolor the node. And what we'll do is we'll give it a random color, and we can do that by using this long instructor. What we do is we give a random hue. So we'll take a CG float in range from 0 to 1, full saturation, full brightness, and full alpha. So it won't be transparent, and then we can add this new node to our console, and we'll add the node to the actual to our array of nodes. We will implement this required initializer. Node singular, and I think for now this should be the most. We'll come back in a bit to add the ways of putting characters and putting strings. I first want to show the SK console in the game scene to at least show it in the game scene so we can see that it's more or less working. What we will need is in the game scene we need a console. So we'll have our RS console, and this will be of type, this will be an implicitly unwrapped optional, and this way we can have in our scene the constant values for the call count and the row count. And then in this view we can create a new console. With our call count and our row count. And then we can add the console to our scene. I think in the view controller we might need to present a size for the scene, but let's see how far we get first. Otherwise this is a very quick fix. So let's build it. Yeah, we need to set a size. Basically what you saw was just one pixel or one character. Fortunately there is an initializer that let us set aside, and we'll put in some magic values. These are based on the height and width in columns, and now you can see that we have all the cells will have a slightly different color. If you resize the scene you will see that the aspect ratio remains the same and the entire scene remains visible. At a later time we will make this a bit better looking, that we always have integer scaling and so on, but for now this should be good enough. So let's get back to our plan. So we're able to show the scene in the scene, but we can't write hello world yet, and that's because we still need a couple of methods to be able to show the letters as well, and that isn't very difficult. We'll start with the first one that will allow us to put a character somewhere on the screen, add a position with a foreground color which will default to white. We'll find the node in our nodes array, so we'll take our position.x times our position.y times our call count plus our position.x. We'll find the texture we need. We'll have our texture. We could just find one here and pass in the character, but I want to make sure that we don't we don't always reload the same character texture if we already did so once. So what we will do is we'll add a very simple cache, and the cache will be a texture cache. We'll create a private variable texture cache, and this will map a string to an SK texture. And the reason we need a string here is because we will be handling more than just characters. So we have our cache here. So what we'll try and do is we'll try and find first if this texture is already in the cache. and then we need to cast our character to a string. And if so, our node.texture will become the texture we loaded. If not, then we will try and load the texture. So we'll find an image named string called texture, or a string called based on the character. We'll set the texture.filtering mode to nearest. We'll set the node.texture to this new texture, and we'll add the texture to the texture cache. And finally, we set the node.color to our new foreground color. This should allow us to put a character somewhere on the screen. We'll also implement our putString method. So we'll have a string here. We'll have a position. We'll have a foreground color. And what we'll just do is we'll have a position. We'll call it a cursor, and it will start at the position. And then we'll, for each character in our string, we will put the character at the cursor using the foreground color that we got passed in, and then we'll move the cursor to the right one place, and that's enough to put the string on the screen. And finally we will have a clear method, and this will just for each node in all our nodes, node.texture. We'll set that to nil. Let's see, it's called foreground nodes. This should compile all right. Next, let's see if this really works. So we'll try and put a string. Put a string hello world at vector 3 by 5. And let's see how far we're getting. So there is some text here. Let's zoom in a bit. So there's some text here, but you will notice that some letters are shown correctly and others are not. And the reason is that both capitals and interpunctation don't have the character itself as the image name. And this is a consequence from the fact that we can't just, for instance, use columns or backslashes in file names, as well as that the export function for Pixelmator for slicing images doesn't distinguish between lowercase and uppercase. So I had to make this list, make the small a or the lowercase a, call it A, and all the uppercase letters have a double letter. This means that we need some form of translating from getting in a specific character to what it's called as an image. Now you could just type in all this information, but I recommend just taking this one from the GitHub, because it's more or less the same. So we're translating from a character that comes in to a string that comes out for all the capital letters, as well as for all the interpunction or all the special characters we know of. And this means we need to change our put character slightly, because we're here directly using the character, but we need to convert the character using this translation table. So what we'll do is we'll create a new variable here called texture name, and this will be our character translation table, and we'll try and find an entry for our character. If we can find it, then we'll use that as a texture name. Otherwise, we'll just cast our character to a string, and then everywhere here we're using a string character, we'll use the texture name. So we'll use it as a lookup key for the texture cache, we'll use it to load the image, and we'll use it to store in the texture cache. And I think this should be enough, because now we should be able to display our hello world in the game scene, and thus have our objectives for this first episode met. So, looks like this is working alright. So we were able to write hello world in our new console on this nice and colorful screen. In essence, if you don't need to add graphics, so if you would make a completely text-based game, this is more or less all you need in the console to be able to do so. So everything we'll be adding here in the future will be added to allow us also to use graphical tiles. But if you are content just putting characters on the screen, like a real traditional roguelike, you don't need much more than this. Perhaps you will need some additional special characters, so perhaps you will add some additional characters to the map. But if you don't want to use graphics like these, then this should be enough. Okay. So that's it for now. Next time we will indeed look into writing graphical tiles to our console. Thanks for watching and have a good day.